Hello everyone, thanks for coming. Today we are going to do a review of our lectures in week 11. So in this week, we talked about fundamental theorem of calculus for line integrals as well as the Green's formula. So for the 1D case, if we are integrating a function over an interval and the function is a derivative of another function, capital F, then the integration of the function of the derivative of f prime is fd minus fa. So this is a fundamental theorem of calculus. For line integrals, things are similar. If we are integrating the inner product of a gradient of a function, Laplace f as well as the r, where r is the line segment, then this line integral is the value of f at the ending point rb minus the value of f at the ending point a, rn. If such line integrals are path independent, which means that if we had two paths, c1 and c2, they share the same starting and ending point, then the values of those two line integrals, integrating over c1 of f dr and integrating over c2 of the inner product of f and dr, they are the same, then we call the line integral to be path independent. For vector fields, we call it a conservative vector field if it's integrating it over a closed path over adding closed paths in a domain is 0. The second condition, equivalent condition, is that it can be written as a gradient of a scalar multivariate function. If it can be written as a gradient of a scalar multivariate function, then we call it a conservative vector field. In this case, if P and Q, they are continuously differentiable, then partial P partial Y equals to partial Q partial X. If it's conservative, then partial P partial Y equals to partial Q partial X. So there are some equivalent conditions in order to define a vector field to be conservative. Then we talk about the Green's theorem. The Green's theorem states that for two functions P and Q, if they have continuous partial derivatives on an open region that contains the domain D is a domain enclosed by a closed curve C, then the line integral over C over the closed curve, closed path C, P dx plus Q dy equals to the double integral integrating on D partial Q partial X minus partial P partial Y. So for the left hand side, we also use the circuit integral notation if C is a closed path. Finally, we can use the Green's theorem to prove that if the vector field F is a conservative vector field on an open simply connected region D, and if both components have continuous first order derivatives. In this case, then we can prove by definition that partial P partial Y equals to partial Q partial X using the Green's theorem, using this theorem. Thanks for listening.